Welcome everyone to this week's Science News. Today I have an update on the reproduction efforts for the supposed room temperature superconductor LK99, the first images from the Euclid mission. We'll talk about more trouble with Starlink satellites, first results from a new simulation for cosmological structure formation, how to steer drops with ultrasound, bacteria that make plastic, an improvement for wireless power transfer, better earthquake warnings, an attempt to predict war, and of course, the telephone worry. Last week I told you about the new room temperature superconductor LK99 that a Korean group claims to have discovered. Here is a super quick update. Several groups all over the world have meanwhile reproduced the compound following the instructions of the Korean group. I'll leave you a link to this handy summary in the info below. As you can see, the first results have been mixed but mostly negative or inconclusive. They pretty much all confirm that the material is diamagnetic, that is, it'll be repelled by magnets. And the stuff clearly has some weird magnetic properties. One Chinese group says the material is levitating as it should be if it was a superconductor, and they have an archive paper to go with it. There's also been a video by a Chinese group claiming they see flux spinning. Flux spinning is an effect in superconductors similar to the Meissner effect. In the Meissner effect, a superconductor floats because magnetic field lines cannot get in. With flux spinning, they cannot get out, so the superconductor is held in place. Unfortunately, there's no paper to accompany the video, or at least I haven't seen it. Another Chinese group also says the material is superconducting, but only at temperatures below 100 degrees Kelvin. They have a paper on the archive. There's also been a theoretical investigation of the structure of the material, which concluded that it's possible that it's a room temperature superconductor, but it might not necessarily be. There have also been fake videos of floating rocks popping up on social media. This one is an example that the creator disclosed as fake to issue a warning, so be careful out there. If you find all that a little bewildering, you're not alone. I think at the moment no one really knows what's going on. What's clear is that the results about the behavior of the material are inconsistent, and there's been no confirmation that the resistivity actually drops to zero at room temperature. But we'll keep you up to date, so stay tuned. This is the most fun we've had in physics since cold fusion. Even the James Webb Space Telescope had something to say about it by recently delivering this image of a question mark in deep space. The European Space Agency released the first test images from the Euclid mission, and they're absolutely dazzling. And yet, they're only a small glimpse at what's still to come. The Euclid mission launched on July 1st. A few days ago, it reached its final destination. That's a small orbit around the Sun-Earth Lagrange point 2, where it now sits alongside other instruments like Gaia and the James Webb Space Telescope. The goal of the Euclid mission is to tell us more about the nature of dark energy and dark matter by creating a three-dimensional map of a part of the universe. Euclid has two instruments. One detects light in the visible part of the spectrum, called VIS, and the other one detects light in the near-infrared. It's called the Near-Infrared Spectrometer and Photometer, NISP. For each of the new pictures, Euclid collected light for 100 seconds, but in the future it'll collect light for almost 500 seconds. This will give us even more detailed images of distant galaxies. Soon we'll know more about what's going on in other galaxies than on our own planet. Or maybe that's already the case. SpaceX has worked hard to make its satellites less disruptive in the visual part of the spectrum. But according to a recent paper by an international team of astronomers, Starlink satellites are unintentionally emitting radio waves. The team used data gathered at the Low Frequency Area Telescope in the Netherlands. During their observation, they saw 68 Starlink satellites crossing their image. 47 of those emitted radiation in the frequency range between 100 and 200 megahertz. That's well below the frequency of the downlink communication signal, which is around 10 to 12 gigahertz. They say that part of those signals don't originate from the Starlink satellites, but are reflections emissions from a French radar system, but still the rest seems to be unintended emissions from the satellites, and they spill into a frequency band that's especially allocated to radio astronomy. While there, strictly speaking, aren't any laws preventing satellites from using that band, it's what we might call a celestial faux pas. But the authors of the study say they're in contact with SpaceX, and the company has indicated that it's willing to try to resolve the issue to protect other astronomical projects. As we've previously reported, Elon Musk's company has indeed taken complaints by astronomers about reflections in the visible range seriously, and the second generation of Starlink satellites is far less shiny than the first. Hello? Hi, Elon. Nah, I think they're disappointed you didn't plaster the sky with flashing X's. No, please don't. I was joking. Elon? An international team of astrophysicists has published the first results from a new computer simulation that shows how galactic structures form in the universe with unprecedented precision. The computer simulation is called Millennium TNG, where TNG stands for the next generation. They've not released a video, but a total of 10 papers that summarizes various studies they have made. Millennium TNG is the largest high-resolution dark matter simulation to date. In this video, you see its cousin, the Illustris TNG simulation, which was impressive already and covered almost 1 billion light-years in size. But the new simulation covers a region that's nearly 10 billion light-years across. This and similar computer simulations start in the early universe with a distribution of only dark matter. They then calculate how the dark matter clumps. Normal matter is not included in those simulations because that's too complicated. For the Millennium TNG project, they run a separate simulation for galaxy formation with normal matter and then match that to the dark matter only runs. Millennium TNG is the first such simulation that also incorporates neutrinos, tiny subatomic particles that lack an electric charge. Neutrinos don't interact with electromagnetic radiation and therefore act like dark matter in some respects. However, we know that they must have very small masses, and if dark matter was just made of neutrinos, then structures wouldn't form quickly enough. Neutrinos have so far been omitted from simulations because estimates say they add up to at most 1 to 2% of the dark matter mass. However, as observations are getting better, simulations have to get better too, and the Millennium TNG simulations could then be used to pin down the masses of the neutrinos. The public data release is planned for next year, so we'll have to sit tight for a bit longer until we can see the ultimate reality show of the universe, Season 1. Scientists in Japan have developed a device to precisely steer tiny drops using ultrasound. This might seem like an arcane art, but it could have a lot of applications, from testing tiny medical samples to studying chemical reactions in unprecedented detail to observing biological processes. This new method works by placing the drops onto a mesh that's hydrophobic, meaning it repels water. Then ultrasonic waves are focused onto the mesh and pulsed into the desired direction. When the waves run parallel with the mesh, they move the droplets horizontally across the surface. When the waves run perpendicular to the mesh, they push the droplets upward, causing them to jump. With a bit of practice control, droplets can even hop into a container. In their paper, the scientists say that their method works for droplets up to 300 microliters, and they can make them jump up to 10 centimeters. That's more than 20 times higher than the previously used method. I think this is really a story about scientists breaking up with pipettes. Look, pipettes, it's not you, it's us. I think we need to see other tools. You've heard of bacteria that eat plastic, but have you heard that bacteria can also make plastic? Scientists in the United States have found a way to genetically engineer the bacterium E. coli so that it turns plant sugars into molecules that can then be used to create recyclable bioplastics. It won't be long until food wrappers are more organic than the food itself. The plastic these bacteria can produce is called polydicatoenamine, PDK for short. PDK is a flexible material that's used for products such as adhesives, shielding for cables, or watch bands. It's usually made out of petroleum-based chemicals, but E. coli can be coaxed into creating the chemicals used for producing it too. According to the researchers, more than 80% of the plastic can be produced this way without sacrificing structural integrity. Even better, they showed that the bioplastic can also be taken apart into its monomers and then be recycled almost indefinitely. If this innovation reaches the market, it could both reduce the use of fossil fuels as well as plastic pollution. So E. coli went all the way from causing urinary tract infections to saving the world. Quite a plot twist. Imagine your phone battery would automatically recharge while you're inside a building. Wouldn't that be great? Researchers from Aalto University in Finland have now found a way to make that a little more likely to happen. The trouble with wireless power transfer is that at the moment you have only two options. You either use what's called the near field of an antenna. For this, you place your device right next to the charger. This is how the existing wireless phone chargers work. The other option is to go farther away and then use electromagnetic radiation that can travel a distance. But you can't just send power into all directions and hope you hit the phone. That'd be incredibly inefficient. So you have to use a directed beam of radiation instead. This is how power is supposed to come down from those solar panels in space. The issue with those beams is that, for one, they have to find the phone, and also if you focus the power in a beam, you have to ask how much of that will get dumped into humans should they get in the way. In the new paper now, they looked at the intermediate distances where you're neither directly at the charger nor are you very far away, so a setting you might encounter in a room. They have found a clever way to couple the antenna and the receiver so that even at intermediate distances, the loss in radiation is suppressed. It's both an analytical study and an experiment. The researchers claim that the new technique allows efficient power transfer over a distance about 5 times larger than the antennas themselves. The antennas in their experiment each had a radius of 3.6 centimeters, so that means they transferred power across about 18 centimeters. That admittedly still isn't much, but if it saves people half a step a day, I'm sure it'll be a great success. Seismologists in France say they might have found a way to predict whether an earthquake is coming on, at least sometimes. They used what's referred to as high-rate GPS time series data from more than 3,000 stations worldwide. They then compared the time series with the timing of 90 high-magnitude earthquakes. In the data, they found a subtle precursor that might signal that a quake is on its way. It's what's called a fault slip, which sounds like gymnastics gone wrong, but it means the sudden displacement of geological features that could be on either side of the fault line where the earthquake is about to happen. In some cases, that happened as much as 2 hours before the earthquake, enough to evacuate people. Unfortunately, the researchers point out that the method also picks up on a lot of false positives, where a fault slip happens but no major earthquake follows. So, as they say, more work is needed. I talked extensively about all kinds of things that scientists have tried to predict earthquakes in 2 previous videos, and let me just say, none of those methods has been particularly successful. Earthquakes have so far been like ninja attackers, taking us completely by surprise, but maybe one day they'll be more like sumo wrestlers, still dangerous, but at least you can tell when they're coming. Researchers in Austria have developed a theoretical framework to explain how conflict arises and spreads. They say that this might help us to predict better when wars arise. The researchers collected data about the number of people participating in armed conflict, international tensions, economic circumstances, and fatalities. They assigned them to time periods and locations and looked for causal connections between nearby locations. This allowed them to create a causal network and to identify situations in which small conflicts snowball into bigger ones, resulting in what they refer to as a conflict avalanche. They applied their model to some past cases in Africa and found it to work well. They also say that their analysis strongly suggests that current events in Sierra Leone are related to those in Liberia. We've historically used a narrative approach to understand war. Statistical methods like this are instead built on the idea that individual decisions matter very little for collective dynamics, and that war is often a consequence of economic circumstances, environmental pressure, and failures of a system that govern human interactions. You see, in the end, we're just big bags of atoms executing the laws of nature. Science is changing our lives rapidly, and sometimes even I find it hard to wrap my head around what's going on. When it seems like I'm missing some essential background knowledge, first thing I do is look it up at Brilliant.org, who've been sponsoring this video. Brilliant is a fresh and new approach to learning with interactive visualizations and follow-up questions. They offer courses on a large variety of topics in science and mathematics. Whether you want to know more about solar panels, neural networks, astrophysics, special relativity, or computational biology, Brilliant has you covered. It's extremely simple to use, allows you to pursue your own interests at your own pace, and they're adding new content each month. I even have my own course on Brilliant that's an introduction to quantum mechanics. It doesn't require you to bring background knowledge and covers topics such as interference, superpositions and entanglement, the uncertainty principle and Bell's theorem. And afterwards, maybe you want to continue learning more about quantum computing or quantum objects. If you're interested in trying Brilliant out, use our link brilliant.org/Sabine and sign up for free. You'll get to try out everything Brilliant has to offer for 30 days, and the first 200 subscribers using this link get 20% off the annual premium subscription. Thanks for watching. See you next week.